So now in this video, we're going to look at the NPN bipolar junction transistor. So this is a demonstration circuit. Probably won't ever really see an LED at the base for a practical circuit. But in any case, we're going to demonstrate what it does. I assume you do not know the transistor at all at this point. And so the transistor has 3 terminals. So it has 3 pins. I'll grab my 2N3904, so we won't be able to read it with this camera the way it is, but it says 2N3904 on there, and if I turn it this way, the pins line up with the description that I have on the board. So flat side is facing us, swiveled it this way, emitter is at the bottom, base is in the middle, and collector is on top. So we'll come back to that later. Now, the transistor has 3 states. So there's cutoff, there's active, and there's saturated. So cutoff means from collector to emitter, it's like a switch that is off. And so the LED in this resistor will not light up. And that also means we don't have any current going from base to emitter, but the transistor doesn't control that. We control it. It does have a diode drop right there. It takes about 0.7 volts for that to conduct, and you lose about 0.7 volts from the rest of the circuit there. But in any case, that's cutoff. The other extreme is saturated. That means we have some current going through the base, and there's enough current going through the base to allow a large multiple amount of current to go from collector to emitter, and as long as that amount is more than what the LED and resistor needs, it provides basically no resistance. It's like a closed switch, a direct connection to ground. The resistor and the LED will limit the current. Now, active region is somewhere in between. We have current going through the base to emitter, but the multiple amount of current that it wants to let through, called gain, is not enough to get the resistor and the LED conducting as much as they would like if it went directly to ground. We have current limited, and that's the active region. So we'll look at those in more details with the circuit. And so here we have the base part of the circuit all wired up with the NPN bipolar junction transistor. Again, there's the flat edge, so at the bottom is the emitter, middle is the base, and the right pin is the collector. You want the collector towards the positive supply and the emitter to the negative side of the supply with the NPN bipolar junction transistor. Make sure you check out the pins on the data sheet if you are unsure. But in any case, this is a 2N3904. This LED looks off, and it probably is off, and I think that's just a reflection from the overhead light, which is actually pretty dim. But if I turn the trim pot up a little bit, you can see we got some glow there. So there's a little bit of current. And now I'll turn it all the way up. The LED is lit relatively bright. There is this 1 kilo ohm resistor that is also limiting current. But in any case, we have the trim pot there. The power supply is set to 5 volts. And I'll show you what the trim pot's doing really quick. It's just resting on that jumper in the front. But we got these 2 jumpers that go to the power supply. They're going to the end pins right there. And the middle pin has its own little row right down there that is connected to the resistor. So that jumper is just resting on it. It's not connected electrically. So the base of the transistor, it takes about 0.7 volts, 0.6 volts to start conducting. Just like the LED takes about 1.5 volts to start conducting. As more current goes through it, it builds up a voltage of about 2 volts, and the base to emitter about 7 volts. So we can go from about 2.2 volts at a minimum. And they'll start blocking a little more after that. The rest of the voltage set by the trim pot goes against the resistor, but there's also the resistive element there. In any case, very little current. That is the main takeaway. That's why the LED did not get very bright. So now we're going to add an LED to the collector. So of course the long lead has to go towards the more positive side, short has to go towards the more negative for it to light up. It's a diode, it conducts in one way. And now we'll grab a 220 ohm resistor. So there's no base current right now, and so there is no collector to emitter current. And so I'm going to turn the power off, or the lamp off, I should say. And let's slowly turn this up. You can see that LED is getting brighter. a lot quicker. There is a little bit of current going through that one, but not enough to really get it to light up. And I'll turn this up a little bit more once I get back in the slot. And there you can see, a whole lot more current is going through the collector to emitter diode than the base to emitter. At some point, it's going to stop getting brighter. The transistor is going to conduct as good as it can. The resistor in the LED will limit current, and that one will get a little bit brighter. But in any case, there you can see it's a 220 ohm resistor. It's letting more current go through than the 1 kilo ohm for that one. So that's the main thing. It's an amplifier. It's taking the current that we are putting there, and it's given a multiple amount. Since it's a 2N3904, it's probably somewhere, whatever we let through here, let's say if it was a milliamp, this will probably let through 200 or 300 milliamps. So this is lower, but the main takeaway is probably about 200 or 300 times. And once that current gets to whatever the load needs, then it just stops limiting current. The load limits the current from there. So in any case, main thing is very small current allows a lot more current. Whenever you're studying transistor circuits, that's the basic principle. Not terribly complex once you understand it. So hope you do now. Thanks for watching. Make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate Patreon if you can. I put a link down in the description. That would help out a ton. I'll see ya in the next video.